are fixed, so means they cannot be easily configured. And they are final, that means they were not designed to be used for other things that the original developer thought of using them. So, for our purposes, Morphic, WikiWorks, SWiki, and SmallWiki didn't go as far as we wished it to go. So what I'm talking about today is about dynamic software. And with dynamic software, I'm thinking about software that is adaptive, software that can change to new needs, that can adapt to new requirements, that is extensible, that developers can extend into that direction, into any direction they need, and that can be customized even by end users. That means even a user of the software can easily change it to its own needs. And to put that a bit into a context, I made this grid. I kind of like this grid. I use that for all kinds of stuff. You will also see it with my TextLint presentation this afternoon. I will have exactly the same grid just with other stuff. So I will start up here. So in C++, static language, writing static software, that is basically the worth of both dimensions, right? So you cannot change anything, you're basically locked in, so we are not going to talk about that. Then in static languages, it is reasonably possible to write dynamic software that is adaptive, right? You just have to build the right object model. Or you have to use one of these extension languages, right? So like Groovy, Iron, Ruby, Iron, Python, JRuby, they all try to add some dynamicity to a static language, Java and C# in these examples. And this is one possibility, but of course in many cases this doesn't really solve all the problems, right? When you use one of these languages, you still don't have necessarily a dynamic framework or a dynamic software. So let's have a look at that. And this is an example that I found on the web. That's from Eclipse, an IDE written in a static programming language, obviously. And this is a small part of the plugin framework. So it's not, it doesn't do anything yet, right? It just makes Eclipse extensible with new functionality for new languages, for new widgets, and so on. But in this presentation, I don't really want to bash on the static languages. Let's leave the C++ past behind and let's focus on the dynamic languages, because there are also the two boxes here that we have. And the examples that I showed you initially, Morphic and WikiWorks and SWiki and SmallWiki, they all kind of fit into this box. They are written in a dynamic language, but themselves they are not really extensible or not really designed for extensibility. And why is that? Why would a user of a dynamic language write static software, right? So, first of all, when you write software, even in Smalltalk, out of the box it's not really configurable. It's static as the source code, because the source code is static. Then it's of course easier, faster. The libraries do not really support to write customizable, or the standard libraries in Smalltalk at least do not really support to write customizable software. Then some people might say it's too complex to make my application adaptive. Or I don't know how to do it. Or the smart ones among us will say, okay, I don't need to write customizable software. In Smalltalk we have this super cool reflection, so I can patch and change and do anything anyway later on if I need to. But in my opinion, this is not really a good solution for most problems. So what I would like to do in this presentation is to focus on this part. So how do you write dynamic software or dynamic frameworks or libraries that can evolve easily in a dynamic language in Smalltalk. And to do that, I collected 6 patterns. And these 6 patterns by no means are all possible ways of writing dynamic software, right? These are just 6 patterns that I found interesting myself and that I had experience or that I encountered during the past 8 years of Smalltalk. So I will now go in the remainder of this presentation through these 6 patterns and show you a bit what I think about it, and if you have other ideas or other suggestions, please let me know, and that will be fun, I think. So, first of all, the patterns are really simple. So subclassing means making your software extensible or customizable just by subclassing, right? And the example here that I would like to show you is C-side. Then extending, with extending I mean to extend software by adding extension methods to a specific class. And here I have the example of Faro that I would like to show you how it makes Faro extensible with extension methods. So these are really basic things. If you're bored about these, just raise your hand and we can go faster through this. Then it starts to be a bit more complicated. So meta modeling, here I will present you the OmniBrowser framework of Colin Putney and show you how you can create software by using a meta model, an extensible software. Then I do one more step and go into the meta modeling, and obviously you can guess what comes here. That will be the Margaret part, where I show Margaret. And then again, a very simple way of making extensible software. This is by composition. This is something very natural in dynamic languages. And as an example, I will present here Pretty Parser, the framework. It was already mentioned yesterday in several presentations, so I think it's a good example to show here. And last but not least, I would like to show you how you can make extensible software by doing transformations or by introducing new languages into your Smalltalk environment. And in this example, I obviously use Helvetia, the language workbench that I've been writing for my PhD thesis in the past few years. So this is a quick overview over my presentation, and let's just dive into the first part, if that's okay. All right. I need the time. Okay. So, subclassing, and with the example of C-side. So I don't think that I need to introduce C-side here. It's a dynamic web framework, and it provides several extension points. So the idea of subclassing is that you add new functionality by adding a new subclass. So that's rather trivial. And the most obvious way, if you have used C-side, you know this way of extending it. So when you want to create a new web application, you mostly start by subclassing the component class, and you override this method render content on it. So that's the most trivial thing, and I think most Smalltalk frameworks somehow provide this kind of extensibility in one way or the other. And basically that's the template method, right? You know that from the famous book, and everybody is familiar with this kind of extensibility. So we have a framework that is extensible just by subclassing and creating our own custom render method or whatever templates we want to fill in. However, that does not make the software yet adaptable, right? When you write a new component, it doesn't automatically appear in your software, or it doesn't change anything existing in your software. You still have to use another way of displaying it or making it a root component of your application. So this doesn't fill all these three properties that we want. So I want to show you another example in C-side that you might not have seen before, or you might have seen it before, but you might not have used it yourself to extend C-side, right? So everybody knows this development toolbar that appears at the bottom of each site in C-side in the development mode that provides all these kinds of fancy features to debug and extend, program and change the application. And these commands that you see down here are basically all individual subclasses of tool plugin. So when you want to create a new command here, you basically just create a new subclass, and it will magically appear in this toolbar. So that's a very easy and common way of making an application extensible. And in Seaside, you really just create a new subclass of this tool-plugin class, and then Seaside always call this all-plugin method, which iterates over the subclasses and creates the commands for each of the entries. And exactly the same way, you can also extend the hellos that you have certainly worked with if you have used Seaside. So here you don't create a subclass of the tool plugin, but of the hello plugin. And it does exactly the same, and it displays all these entries here. Yeah?
Oh yeah, but here you are using meta programming, because doing also classes.
Yeah. I didn't say that this is forbidden.
Okay.
So, of course, we use all the tricks of programming that are available in Smalltalk, right?
Okay. Yeah.
So, this uses the template method pattern. It's really simple, lightweight. The cool thing is that it works basically across all the platforms. So if I write it in Pharo, it also works in Gemstone and Visualworks and GNU Smalltalk without any changes or anything special. With the other tricks that I will show you later on, this is not always the case, right? And it also requires no other infrastructure except reflection, but we take that as given. It's not voodoo reflection, right? It's quite a standard reflection. And because it's so simple, a lot of frameworks also use that, right? So Monticello, the source code management system, for example, has different repository types, and these are essentially just subclasses of a common superclass. In Omni Browser, the commands, the code critics rules, the text lint rules that I will present later today, in peer, command, view structure, all follow the exact same pattern for extensibility. So that was the first part. That was simple. There is another one about class extension that is simple too. And here I would like to show you Pharo. And the idea of this pattern is that you add new functionality simply by adding a new method. It's actually very similar to the previous one, right? So in Pharo we have these nice short menus. And all the items in these menus are essentially made by methods like that. And the key thing here is this annotation that we have, world menu, that tells the system that this is code to create one or more of these menu items, right? And when somebody clicks on the desktop to open this world menu, the system uses some code to find all these methods that build the world menu, and it creates this menu quite simply by just calling all these methods, right? With a builder object that knows how to build this menu. So that's the extension mechanism. So it's also quite simple. It's lightweight. It has some disadvantages, however. For example, it uses or people tend to make very long utility methods when they certainly are forced to put everything into a method, right? The subclassing is kind of more object-oriented because you create a new class and you have separated your new method, right? And of course it also encourages class extension. So often these methods are not put into your own class. In the example here of Pharo, they put in your own class, but some system might expect them to have these pragmas in a specific class, and so require you to create a class extension, which is not liked by a few people, but I think this is not really a problem in this case. If you don't like pragmas, or if your system doesn't support pragmas or method annotations, then there are various alternatives. So you could use naming convention for selector names. Omni Browser used this pattern for a while, but now it also uses pragmas, which is much faster. You could use naming convention for protocol names. That's a bit ugly. The refactoring browser used that pattern. Was also changed to subclassing now. Or you could just put all methods or say all the methods in a specific class. are used as extension methods and then automatically collected and called by the system. So these are alternatives if you don't like pragmas or if you don't want to use pragmas. But basically the basic idea is always the same. Yes?
So, now, these are mechanisms by which usually you found, you mentioned the refactor browser a number of times already, like how you added extensions to it. But do you have any thoughts on what happens when you want to remove the functionality? Because sometimes when you add something that's active, removing is not so easy.
Well, for example, in Pharo, for this menu example, you can basically create exactly the same thing here, and you tell the builder to remove again some menu items. That is the way how it works in this example. In Omni browser, there is a different pragma or a different method annotation that again can remove menu items if you want them to disappear or to replace them with something new. So you can exactly use the same mechanism to also remove stuff again. But it requires you to improve your collection or building functionality, of course. Okay. So there are other uses of that. For example, in peer, we have different kind of link types that use this pattern. Or then the primitives in the Pharo compiler use that pattern. So if you want to add a new primitive type, you just add an extension method into the compiler with the primitive pragma, and then it automatically supports this new primitive type. And I've already talked about the Omni browser commands and the obsolete commands as they are called there. So that's the extension pattern. Let's now move to a bit more elaborate pattern, if there are no more questions. Okay, so meta modeling. So the idea here is to create the first class description of the domain that you can introspect and reflect upon to do something. And the example that I would like to show here is the Omni browser by Colin Putney. It uses a meta model in the background. And the interesting thing, or what Colin noticed here, is that basically the standard smalltalk browsers, in this example it's the hierarchy browser, a variable browser, and the normal system browser, they basically all have this common navigation panel here on top. And what now Colin did is to build a meta model that would describe and run the browser from this central piece of the Smalltalk browsers, right? So in this example, to model this simple system browser, what he does is he takes or he creates objects that represent the different parts of this panel, and that looks like this. So it starts with a node that is invisible here in the user interface, but that represents the system environment. And then each of these parts has information on how to navigate to the next list item, right? So the environment knows all the categories, and the category knows has a filter, so that's what is displayed down here. So it can either display the classes, the comments, or the instances. And then from there it goes into these parts, as I said, and displays the things in the second list, right? And then this goes on to the protocol. Here the different parts are reused, right? It doesn't matter really if a protocol is on the class or on the meta class side. It has the same functionality to retrieve this information. So whenever you have a class select, it shows the whole protocol and all the individual protocols of the selected class or meta class. And then it goes from the selected protocol to the method. So you build a model like that, and then the Omni browser engine can automatically build you this navigation interface. Now, and then of course you get the full browser. And the advantage of having such a meta model is that it's totally independent of the user interface, right? So for example, there is also OB Web. I don't know if you have tried that ever. It's a Omni browser for the web. And renders basically the exact same browser with the exact same functionality in a web window. So that's really a browser window. You don't really see that because the toolbar is hidden. But trust me, that's a web application. And then there is also Mars that uses Cocoa to display an Omni browser in Cocoa and provides a native user interface, which is really very cool.
So, Lukas, if I was to omit the meta class part of that graph, the instance and class buttons would disappear. They would not be generated because they're not.
Here?
Yeah.
Yeah, I don't know. That's probably based on an older version of the meta graph. I'm not sure why it doesn't show the comments here.
Because I didn't put it there. I was in time and
you tweaked the meta model, huh?
Yeah.
To make it simpler to get the Cocoa interface running. Yeah.
Yes.
But ideally, that should be identical.
Circumstantial. It will be back.
No, the question is if you leave out parts of the meta model. So if I left out the meta class part of the meta model, the engine would discover that the instance and class switch was unnecessary. I mean, if I wanted to produce something which hid meta classes from newbies, all I have to do is remove meta class from the model.
Yeah, then it would still put the filter for the comment and the instance, right? If you would remove both, then it wouldn't show a filter at all. If there is no filter but multiple outgoing edges, like you see, for example, here, then it just concatenates the two lists, right? So in this case, it puts the all protocol on top and then all the protocols of the selected previous element. If you would put a filter here, you could get two buttons here, one for the all thing and one for the other protocol, which doesn't really make sense, but it would be possible. Okay, that's an example of a meta model. So it's user interface independent. You can do all kinds of domain-specific reflections, so you know what is currently selected, what should be displayed in the other panes, etc. It is highly extensible with the other mechanisms that we already learned before. So Omni browser, for example, uses method extensions to extend the meta model in a similar way as we saw before. But it can cause meta confusion, so people can be overwhelmed or do not understand how the model works. So it sometimes requires a bit that you spend some time on the meta model to really understand how you can change it and modify it. And also it can be limiting or slow. So Omni browser is often criticized for having this fixed series of panels up there. With Omni browser, you cannot really do anything else, right? The meta model requires you to have these panels up here sort of as a central representation of the navigation and the selection. And anything else is not easily possible to do unless you change the meta model. And it can also be slow, which I don't think is the case in Omni browser, but some people think it is. Yes?
Yes, I have a question. I don't understand why you're calling it meta modeling and not just modeling. I mean, you're showing an example that is working on the meta model of Smalltalk, but I mean, that technique is...
This is actually a model for this particular browser, for the system browser, right? But below that, how this is implemented is a meta model, because it describes how the generic browsers work.
Oh.
This is the model that describes just this particular browser. Okay, sorry, that was maybe a bit confusing. That's the meta confusion.
Well, if it's not meta confusion, that's fine.
Not yet, no.
If it's not too complicated, could we see the code where you configure the model?
Yeah, well, I don't know if I have an image, just...
Never mind.
Model, Then there must be a meta build or something. Yeah, meta graph builder. So that's the code that instantiates the class node. And then here you see it uses method annotations to configure these nodes of the model. So for example, it says how to navigate to the parents, how to navigate to the all categories or all protocols, how to navigate to the protocols, and then it assigns another node there, so to connect these arrows that you saw in the previous thing. You also specify how to automatically select some things or how to add filters. So that's a different kind of filter, not the one with the buttons, but a filter that adds icons to the list icons. So it's really configurable. Alright, so there are of course other frameworks that use meta models. For example, there is Glorp. I'm sure most of you know that. There is Glamour, the framework to script and build browsers. It also has a meta model that is very different to the one of OmniBrowser. The multi-channel code model is kind of a meta model, like the smalltalk meta model, but for versioning code. Announcements can also be seen as a kind of a meta model, or of course the Magritte meta model. And that's what we will dive into next, because that takes the meta modeling one step further. Any questions so far? Other famous frameworks that I forgot to mention here? I'm sure there are. Every larger Smalltalk software has in some part some kind of a meta model, I assume.
An incomplete implementation of Magritte. Every large Smalltalk application includes a badly specified implementation of Magritte.
Maybe, yeah. Okay, so let's have a look at Magritte and that meta modeling. So the basic idea here for meta modeling is that you don't only create a first-class description of the domain, but also a first-class description of the description of the domain, right? Okay. So let's just quickly rehearse what a meta model is before we dive into the meta model, right? So when you have an application and you want to, you have an object, for example, an address object, you can, additionally to this object, obviously have a class, right? But this class, or the Smalltalk class, typically does not convey too much information, or not enough information that we might be interested in, right? And what Magritte does is it associates meta information with objects or classes in the system, with additional meta information that the Smalltalk reflective model cannot tell us. So for example, in case of this address object, the description is sort of a container of multiple description objects, and then we have a string description, a description object basically for each attribute in the class. This one-to-one mapping doesn't really necessarily need to be there, right? There can be attributes that are not described, or you can even describe methods and so on. But in this simple example, I just described the attribute. So it says, for example, this is a string description, and the label for this value is street. And then I have a number description for the postal code, and it says this is a required value, the label is postal code, and it must be in that particular range. So I can specify all these kind of additional information that the Smalltalk meta model cannot really, or the Smalltalk class model cannot really tell me. And then I can do essentially the same as with OmniBrowser. So this is nothing really new. That's just a model, right? That's the model. That's the meta model. And then I can do things as I did with OmniBrowser. So I can, for example, create a morphic interface. I can create a C-side interface. And I can do all kinds of other weird or not so weird stuff. For example, I can build viewers, editors, reports. I can generate documentation from that. I can do data validation, as I showed you. I can process queries. I can filter objects. I can serialize objects. I can copy object in a specific way that I described with Marguerite. I can index object in a database. I can initialize object with default values from the meta model. I can make objects extensible and adaptable, and we will look at that just in a second. And yeah, these are some things that I have been doing with Marguerite, but other people have been doing other weird stuff, so this is by no means a complete list. So, what we looked at up to now is that the developer defines the meta model, and the end user just works on the domain model, right? The end user edits the address object, and the developer specified how the address looks like, what it needs to validate to be a valid address object. And this is a standard thing that happens in most meta models, right? That's exactly the same in Only Browser, for example. The developer is up here, the end user is down here. Now, with Marguerite goes a step further. Marguerite doesn't only let end users edit the domain model, but also the meta model. And why is that possible? To look at that, we have to quickly look at a UML diagram of Marguerite. So, a Marguerite description is the entity, the basic entity that describes objects in Marguerite. And it's a subclass of object. And Marguerite adds some extension objects to some extension methods to object that say that every object in the system can be described by Marguerite's description object, right? So, key idea here is that this means that the description objects themselves are also described by Marguerite's description objects. So I can basically, because this meta model is described by a meta model, which is again Marguerite, I can provide automatically an editor that allows me to edit the meta model. And I'm quickly going to show you that. So we end up with a runtime additive object model. That means an object model that can change because the user or the end user can change the meta model. And we gain end user customizability. And I would quickly like to show you a short demo. So that's a slightly older version of Peer. And if you have used Peer, you know you can edit a page, for example, and say hello Argentina. I probably cannot type, but it doesn't matter. So you see, it's a fully functional Peer instance. And the special thing here is that we allow the users also to edit the meta model of this Peer instance. So I have the comment down here, edit meta model, and now I'm editing the meta model of this page basically. So it already has two entries. As you see, it has a string field for the title and it has a memo field for the contents. And we can, for example, add another memo field to keep track of notes. We can say, okay, that must be a searchable field and it should have three lines of text. And when I save that, I automatically get this new field in the editor. And of course it's persistent, so I can save it and it automatically keeps track of this value. And when I type something, it should also be searchable because I specified it to be searchable, so it shows me this page as a hit for foobar. So I can change in this particular context of the Peer content management system, basically the complete meta model if I want to, and if I have the permissions to do from the web browser without that I actually need to touch the code. Is that okay, or is that too meta confusing? Good. So let's first check my time.
I have a question.
Yes.
How do you stop the meta regression? Do you stop it or not?
No, it's basically each description is described again by the same description. So
you can go.
You can go on, but okay. It doesn't make sense. No, I've never gone beyond.
No, because for example in the object and smalltalk meta model you have the link of meta class and meta class.
Yes.
You could do something like that.
Yeah, no.
That was key.
It's basically an infinite chain of meta models. Okay. So, as you saw, this kind of meta model is very powerful and flexible. You can change your application without actually changing code in your source. It becomes end users programmable, so you can give, for example, administrators the possibility to change certain aspects of your application. But it is again a bit more complicated to work with, right? You can get meta confused, not just meta confused. And again, it can be slow. So depending on what you want to do, it can be reasonably slow. So for example, for the search, we did some benchmarks a few years back, because when peer searches a large website, and it uses really the meta model for each object in this huge graph of millions of objects, the search is about twice or three times as slow as if you would just go through it and check every field. Of course, you can optimize that in various ways, but you have to keep in mind that if you have this indirection, so you don't hard code everything in your source code, it can be a bit slower. But now that Elliot made it 3 times faster, that doesn't matter anymore.
Right, but you have the compiler, and you can generate search methods on the fly.
Yes, indeed.
That's the right way to do it, right?
Yes, you could do that. With Magritte, I don't do generate code normally. However, there have been people that have generated code with Magritte. Personally, I don't like too much code generation because, you need to regenerate it all the time, right, when you change something. Of course, Magritte can help you to detect which parts need to be updated, etc. But normally, I just kept the flexibility of the objects and run everything through the object instead of generating code.
But you think of Alan Knight's automatic query generation for SQL. There's some clever code generating tricks. It would be very easy just to construct a block and then throw it away.
Yes. Yes, that can be
wrap it in the right way. It's hidden. It's not like you cache these things.
Mm-hmm. Yes. I haven't looked at it, but yeah, that's definitely possible. Other question, comments? Other users? I honestly haven't found that many examples of meta models in Smalltalk. Of course, DoubleDB is has supposedly kind of a meta model behind. Otherwise, the whole functionality wouldn't work, right? Otherwise, people wouldn't be able to change the tables on the fly, etc. So there must be a meta model, even though I don't know the code. Gaia, or however that is pronounced, is an issue tracker that also has a kind of a meta model behind. I don't think it's Magritte, but I might be wrong. Are there other examples that people know? How is my timing?
20 minutes.
Okay. So I think I can make it. Okay.
We can give you more time.
No, it's okay. I don't want to spoil your coffee. So, the next thing is actually, again, something very, very simple, something very natural that you do basically every day when you work with Smalltalk. So before we go into the last step where we talk about transformation, let's have a look and relax a bit with this composition. So the idea of composition is that you build something new by composing existing parts. And the example that I want to show you here is what I did for my PhD, and this is about composing different languages with each other, right? And what you see here is a Smalltalk method in the Smalltalk debugger, and right in the Smalltalk code you have an SQL statement, and right in the SQL statement you have a Smalltalk statement again, and in Smalltalk you have a native regular expression, something that you usually cannot do in most Smalltalk implementations I know. So here you have really various language extensions that are composed in some way together. So when I started to work on this topic, I asked myself, how can this be done, and how are languages, how I can compose these different languages. And when I looked at existing technologies to represent languages, obviously I looked at parsers for different languages. And most today's parsers look either like that or like that. And as you can imagine, this is not really easy to compose or to put together that with another language, right?
For the English better now. Microbes and series of numbers.
So what I did is I looked a bit around what else is around there to represent languages and to work with languages. And Gilad already yesterday mentioned parser combinators, and that's essentially what I ended up with. So parser combinators are simple building blocks or primitive parser objects that can be composed and rearranged and reflected upon. And then additionally I use Scannerless. That means I don't have a separate scanning step. So typically when you define a language, they are defined in two parts. First of all, you define what kind of keywords and tokens you have, and then you define how you arrange them. And with Scannerless grammars just means that this is basically put into one entity. And that makes it much easier to compose, right? You can imagine that you don't have to compose two independent entities. You just have one thing that you can compose in some particular way. So let's have a look at a very, very simple example. I will come back to the SQL example later on, but let's start with something simpler. So this is the grammar as you would write it to parse an identifier, for example in SQL or in Smalltalk. So it's a letter followed by multiple 0 or more letter or digit characters. And this is what is kind of a flow diagram that would describe that kind of grammar, as you typically see it in language methods. And in Petit Parser, the framework that I use to describe these grammars, I changed that a bit. And this is now what parser combinators are, right? So I have an object that represents this sequence of this and this entity. So this entity is just a simple parser that parses letters in the input stream. And then I have an object for this many or 0 or more, right? Then I have a choice between letter and digit. So you see it's a more complicated grammar can be built from very simple parts. So I have a simple parser that parses just letters or just digits. And then I compose them in some nice way to get a complete parser for identifiers. And now, as soon as I have this infrastructure, I can write arbitrary complex grammars, right? I can write an SQL grammar, I can write a smalltalk grammar, I can write a regular expression grammar, and then I just need to compose them. And I can use exactly the same composition mechanism as I use here, right? And that basically is how I write it in Smalltalk. So I use these symbols to represent these parsers. That's a bit, I'm cheating here a bit. I always have to say yes parsers because I don't really want to reuse these symbols as or implement the parsing functionality in the symbols themselves, right? So as parsers just returns me these objects, and I use this nice internal domain-specific languages with the binary operators in Smalltalk to represent the sequence and the choice. And the star means 0 or more, like you would expect from regular expression, right? The character to represent 0 or more is also called a star operator there. So that's how you write a simple parser. Now since I have these graph of grammars, I can basically just compose them using the magic composition operator that I just call plus here, to have a customized Smalltalk version, and then I can get into a situation like you saw previously in the screenshot. So yes.
Can we just back up just to point out what it looks like in newspeak? So just the one before. next one. In Newspeak, because you have implicit receivers, these become messages, and you lose the hash, and each is a message to self. Right? Mm-hmm. So it looks even cleaner, and you have letter, comma, etc.
Yes, yes. Actually, I can write it like that in Helvetia, because I can write a parser for this language, so that's kind of a meta parser, right? Yeah, basically all these patterns really compose and work well together, right? I can basically combine any of the 6 patterns with any other of the 6 patterns. And I can write the grammar like that. And this is absolutely identical to that. Yes?
So when you compose two completely foreign grammars, obviously there could be ambiguity, so that's resolved basically on some sort of prioritization.
Yes, yes. I'm not going into that too much. Well, not at all, actually. But you can watch the presentation on my blog if you want. There, that's my defense presentation. It goes into all detail of these ambiguities and how you resolve them and so on. But just to make it short, it's basically based on order. So whatever comes first takes precedence. So in this case, Smalltalk would take precedence over SQL, and SQL would take precedence over regular expression. But there are a bit more fancy stuff that you can do about it. It's kind of cool, but it probably goes a bit too deep for this presentation. Other comments? Okay. So this was how you compose primitive graph parsers to more complex ones, and then even compose parsers from different languages. So what is appealing about this model? It's like Lego, right? So you have these Lego pieces, and you can compose into anything new that you want. This is highly extensible. You can even buy your new Lego parts, right? If you want some new fancy stuff. Or you can, in Smalltalk, you obviously write these Lego parts yourself if you need something new. And then the cool thing about Smalltalk, as opposed to other languages that are maybe not that good at composition, are the binary operators, right? The binary operators that you can define on classes make it really nice to build a cute little language like this one, where you can compose the different parts easily and make it even readable, right? So, who uses this composition thing? I'm sure there are thousands of other frameworks that use this. I just picked a few that I particularly liked. So Brazil takes, for example, the composition to widgets in the user interface. So it provides a similar language in Newspeak to compose different widgets together and to build really complicated user interfaces like trees or lists and so on, just by having primitive parts that are composed together. Then, to some extent, of course, also in Peer and C-side, you have the components that you can compose in arbitrary new ways, right? Basically, with any widget library, this sort of works. It depends a bit how elegant that is. And to quote again the refactoring engine, there you have the change objects that also and is also using the composition to represent more complex changes using various smaller primitive changes. But I'm sure there are many other examples, right? Okay, so if there are no questions, let's have a quick look at my last example of making your system extensible by transforming. And the example that I use here is Helvetia. So the idea is here that you build something new by transforming or changing existing parts. And I will just pick up from the last examples where I composed different languages with each other. And Helvetia provides this language box model that is essentially the description of this plus operator that you saw in the previous example where I took Smalltalk and added regular expressions and SQL. So a language box is essentially a first-class representation or a meta model for a language change. And it has different parts that I'm quickly going to look at. So, for example, first of all, it has a scope. That means where is this language extension active in the system. And this can be either done by through the browser. You can add or remove or import or remove a language extension from a particular scope in the system, or the language extension itself can say if it's active in the whole system, in certain packages, certain classes, or methods. I will do a demo afterwards. So if you are a bit lost, this is my fault. Then the concern is about the semantics of the new language that you introduce. And this is essentially a transformation of the input, of the parse input, into a representation a tool or the compiler or the VM can use. So, for example, you can define how this language is executed, how the code is executed, how it folds, for example, in the editor, how it expands in the code completion. Maybe you want to specify custom refactorings, custom error correction, search things, highlighting, language concerns. No, that's the title, sorry. Context menus, navigation, etc. So there is plenty of possibility of how you define the semantics. Yeah, I should have changed the title. That was stupid. It looks exactly the same. It's the same font. At least it's consistent. And then last but not least, and that's the most interesting part, is the syntax. So how do you transform or compose the syntax? And here we really just compose these different languages to a common host language. And this plus operator, as I said previously, is essentially an information of where to use the simple composition that we saw in the previous pattern of how the two languages at which points they connect. I'm not sure if I have another slide on that, but I think I'm just going into the demo now, and then everything will be much clearer, I hope. So, what are you laughing?
Your class name.
Oh, no, that's not a joke, actually. Yeah? I'm sure some of you know the programming language, which is a really weird programming language. But it serves as a good example because it can be easily implemented into Smalltalk. And here you see a normal debugger, normal Smalltalk debugger, and you see the brainfuck code down here. And you also see here the visual representation of this brainfuck machine. And I can step through this code, and you see when I step over the plus, it increments the number at the current pointer. I jump over the block because I would have to need to press into to get into that loop. And then we need to see the transcript up here. And you see whenever I hit the dot, it prints something on the transcript. So, but you see, even for weird languages, the Smalltalk debugger is really useful. It's like Elliot said yesterday for C. You can start to understand such a programming language and write such a programming language if you have if you have the nice tools for it. So that's a very funny example of language boxes and how they introduce a new language into Smalltalk. In this example, the language just replaces the existing Smalltalk. What I wanted to show you, or what is more interesting, is the example here with SQL, where we have different language extensions mixed with Smalltalk code. And what you see here is we have syntax highlighting of that, so I can change the code, and when it's an invalid SQL statement, it doesn't get highlighted, right? And I can compile it, etc. And I can also use the debugger to step through that code, but it's still broken. Those that saw it at ESOC is, I still haven't fixed it, so I'm sorry, I'm not going to do that. But what I can show you is how you can add a new language extension. So, for example, if you would like to use Roman numbers to in this method, you can just say add a new language box, and then there are various language extensions that we have available here. So, for example, the Roman number literals, and I can from then on use Roman numbers here, and they again get highlighted. If I type an invalid number, it doesn't get highlighted, and it gets compiled correctly as the right number. So you see here an example of 3 language extensions mixed into each other. Maybe just a quick look at how the Roman numbers work, or how the Roman numbers are implemented, because I'm already over time. No, then there's no look into that. Yeah, but I have still 7 slides. I can show it afterwards. So,
quickly show us though any of the meta level where you know things are
Why? He asked you do it.
No, it's a triage.
yeah, so that's the basic composition. That's where the whole magic happens. For the Roman numbers into Smalltalk. So what it says is, you give me the grammar that is currently active, and then it returns a change object of this grammar. So it says, whenever a number literal is expected, you can as well expect a Roman number. And the Roman number is a petit parser grammar that is defined as I showed you in the previous pattern. Okay, I make the rest very fast, and I'm almost over too. So, of course, when you have a system like Helvetia, you can easily build new languages, and that's very generic, and you can almost express anything you would like, and that is maybe not nicely supported by Smalltalk. However, it requires usually extra infrastructure. In this example, Helvetia, and it might be difficult to learn and apply because you have to use a new language. But if you use Helvetia, you at least have the debugger, so that already helps a lot. So there are many examples where people have been writing new languages. So for example, the refactoring engine has this complicated language to match parse tree nodes and to search for Smalltalk code. That's a kind of the use of this pattern. Then various people have implemented various compiler hacks. I don't really call this a real language extension. That's really ugly. It also usually breaks all the tools and everything. And then, of course, what we saw yesterday. So this is a very nice example of such a dedicated language that makes your domain more accessible and easier to extend. So, is there anything else? Yes. Okay. One question.
Yeah, that's my problem for it. But I really didn't get why you call this transforming.
Because it transforms from some other domain or some other language into something executable, something accessible in your programming language, in your Smalltalk environment. So in the case of Helvetia, this is always transformed to Smalltalk code, right? That's why I called it transforming. Maybe it should be called domain-specific language, but then again, it didn't really fit into my verbs because each pattern was a verb. But yeah, you got me there. Okay, so is there anything else? Yes, of course, there must be a lot more, but these are just a few things that I think were interesting, and I hope that you found interesting too, that I encountered in the past years. And especially those last 4, mostly focused on how to make tools and languages extensible, right, and customizable and adaptable. And these 2, and also this one, these are really simple ones, and I hope that in the future a lot more Smalltalk software will be really more dynamic and even easier to use and extend and change. Now, there is of course the question, and that's the work of Jorge Recia, also at the University of Bern, and he asked himself the question how to make the object model of Smalltalk itself extensible. And I'm not going into details here, but that might be a possible future direction of how to write dynamic software in a dynamic language. And what he does is he does not only associate, as the VM already does, any object with a class, but also with a structural meta object. This is a meta object that describes somehow how the object is physically represented in the memory and how it behaves in the memory. And these two things go beyond what Smalltalk does. So it's kind of similar to Magritte, but more on a level for programmers to do fancy stuff. So what I hope after this presentation is that really people start to write extensible software that can be easily adapted and changed. Thank you very much. Are there still questions? Or is the coffee?
Well, sorry. Yeah, so I just wanted to ask what your own thoughts are on the benefits and dangers of pushing a Magritte-style description framework down into the language, because you could have that, in-class declarations with first class.
Yeah, sure.
And stuff.
Well, the danger, of course, there's always problem of portability, right? You would need to somehow change all the Smalltalks to support that, or just stick with one Smalltalk. The advantage of Magritte is that it's portable across most dialects today, which makes it basically safe to use, right? But to put it into the language, that would be really interesting, and this is, I think, also the direction Albedo is going and trying to do. Yes.
Yeah, I mean, the danger is that you end up with a statically type language, right? If you think that you should enforce these rules,
yes,
right? Because there's this lovely separation. It's like.
But yes. Yeah, pluggable types is another example of exactly that, right? Yes. There are some pluggable type systems that are really powerful and that go into the direction of Magritte. Yes, I should have added those to the list. Other question, comments? Yeah.
When you have one model, then you have one problem. In this presentation, where is the meta problem? It's one question. Second question.
Yeah, just one question at once. So when you have one problem,
one model, one problem.
Yes.
One meta model. Where is
where is the problem? The meta problem. Yeah, the meta problem is what I initially showed, that it's sometimes very difficult to get code beyond what the original developer thought. And with these techniques, if you employ these techniques in your software, it's easier for your users of the software to go beyond what the developer or the requirements initially said, right? You can do more, you can adapt it, you can change it. It's more flexible. That's the problem all these patterns try to solve in one way or the other.
You don't have the definition of meta model philosophy. The definition of the meta model is method of result and some problem.
I don't understand.
And you have the one method. Now, one definition, the meta model. Okay? The second.
You can always use multiple meta models together, right? Or the Smalltalk meta model is always there. Magritte is just an extension to that, right?
You have meta model.
Yes.
Meta model. Everything.
Elliot agrees.
Yeah, it's like meta classes, right? Everything's an object. Everything's an instance of a class. The meta model is represented in objects, so these descriptions apply to the meta model. And eventually you come to a point that says, I have no distinguishing information about this. It's just a base object, right? So you know, that's how you end this infinite regress. And if you want to extend it, you can. You know, you can keep on counting to infinity.
Sure.
But eventually you get tired.
Yes. Okay, there's a second question.
How many applications in general of math, of mathematics, use this method? What problem do you recommend to use this method?
For which kind of problem?
Would you recommend applying that?
Yeah, basically for any software that you would like somebody else to use.
Okay. Thank you. Coffee break.